I have an interesting question through which we will understand the concept. The question is as follows. We are expected to find the number of solutions of the equation x positive 2 times tan x is equal to pi over 2 in the interval 0, 2 pi, and we are given a list of choices. Is it 2? Is it 3? Is it 4? Is it 5? Right? So we will have to solve this question. Now before we could solve this question, we will have to, as always, I will consider the given equation. Consider x positive 2 times tan x is equal to pi over 2. Now there are a few observations we will have to make. Now this particular quantity, the expression which is on the left hand side, has got x and tan x. Now whenever we have expressions involving sin x and cos x, or sin x with tan x or cos x with tan x, we can approach the question using trigonometric identities, but in this case it wouldn't be possible. Instead of saying it would be possible, the approach would be complex. So the best way to approach this question is by graphical means. Through graphical means, we would be able to solve the question with ease, right? So that's the important part in this. So for that to occur, we will have to slightly modify the given equation. So I would place 2 times tan x on the left and I would move x to the right. So I got pi over 2 negative x. Now this particular equation can be treated as 2 different equations. So I can take this as y is equal to 2 times sin x and y is equal to pi over 2 negative x. So I've got 2 functions for which I can draw the graph. So foremost, what I would like to do is I would like to draw the graph of y is equal to tan x. Now how does the graph look? Now let me just place the axis. So there will be an asymptote. This is the graph of y is equal to tan x. There will be an asymptote at pi over 2 and at 3 pi over 2. That's fine, that's enough. And then the graph would start from 0, it will move up. So let us draw the asymptotes first. So this is the first step you got to do. You will have to plot the points and then draw the asymptotes. After you have drawn the asymptotes, you will have to then plot the points where the graph is making the intersection. So clearly between pi over 2 and 3 pi over 2, there is a hit on pi. And between 3 pi over 2, after 3 pi over 2, you have 2 pi here. So this is 0, pi and 2 pi. So make sure that you have that point there, 2 pi. So now the graph will actually, so starting from 0, so this point is 0, right? So the graph will start at 0 and it will move up like this. That's the first step of the graph. Of course, the graph will then flow down. Okay, so I don't want to draw that point. If I were to draw that point, I would have to make the subsequent markings. So having drawn the first part, coming to pi, the graph will flow from pi like this, and then it will flow down. So since pi over 2 is an asymptote, this is the way it will flow. Next, coming to the point 2 pi, the graph will, of course, we will have to have a asymptote there, but for this we don't need to exclusively place that. So clearly we know the graph is going to flow like this, so that's fine. And then the graph will flow down like this, right? So this is a beautiful graph for y is equal to tan x. Now you might be wondering, yes, you drew the graph for y is equal to tan x. What about y is equal to 2 times tan x? So you don't have to worry. So the intersecting points and the asymptotes will stay intact. So you don't have to worry about that. So that is the first step. Now the next step is we will have to draw the graph for y is equal to pi over 2 negative x. Now this is a straight line, right? Now since this being the straight line, we will have to take the first point. Say when x is equal to pi over 2, what happens? When x is equal to pi over 2, we get pi over 2 comma 0, right? So at pi over 2 we have an intersection. So just go and circle it up, because at x is equal to pi over 2 we get the point 0. So that would be the coordinate. So that is one particular point. Now what I wish to do is I would like to take the value x is equal to, say for example, what happens at 2 pi. Because why am I focused on 2 pi? Because the interval given to us is 0 comma 2 pi. That's the main thing. So if I were to take x is equal to 2 pi, then y will be equal to pi over 2 negative 2 pi, which is nothing but pi negative 4 pi divided by 2, which is equal to negative 3 pi over 2. So the coordinates for this is going to be 2 pi comma negative 3 pi over 2. So at 2 pi we are having a negative 3 pi over 2. So that would be somewhere over here, approximation. Now the point what we want to do is we will want to, already we got 2 points, so we will have to connect these points. So if I were to connect these points, the graph, since it's a straight line, right? So it's a straight line. So if I were to make the connectivities, the graph will flow like this. That's it. Now the most important question is you will have to find the points where the graph is intersecting with the tan x graph. Now let me just see the intersections. So clearly there is an intersection here, there is an intersection here, there is an intersection here. So 3 points of intersection. And what does the solution wants us, or I should say the question wants us? The question wants us to find the number of solutions of the equation x positive 2 times tan x is equal to pi over 2 in the interval. So without even stressing ourselves, we have obtained the solution. So in this case, the solution is going to be 3, and I can specify it. Therefore, the total number of distinct solutions that are possible is equal to 3. So that is the end of this particular question, and thank you.